Okay, so to finish off section 2, we're going to look at application of these three-dimensional vectors. So this is talking about a situation where you see where you have like trying to suspend something from a ceiling. So if you ever go to any decent museum, usually has different displays and stuff that are actually hanging. Well, the thing is, they're not always centered. So you can make all the ropes the same length, and you might adjust for how much weight they can hold, because depending on positioning, there's going to be more force applied in some places than others. Okay, that's what this looks at. So it looks at a 480 pound weight that's supported 3 ropes. Okay, the weight is located relative, so they basically set up an axis at some point on the wall so they could do the calculations. The weight is relatively at 0, 2, -1. The ropes are tied to points 2, 0, 0, 0, 4, 0, and -2, 0, 0. Find the force on each rope. Okay, so they give you the diagram already. Now the problem is, well, I need to figure out some vectors first. Okay, what's the blatant obvious vector they give you up there? Well, S is the actual point. Well, you're looking at those, that W. But from S down, yes. So what would be, if I wrote that out as a vector, what would that be for that vector W? So you're representing the amount of force pulling straight down. How do you represent that? Well, if gravity's going straight down, right? Yeah, 0, 0, and -480. Because it's 480 pounds, right? I have to go back for that part, but yeah, 480 pounds. There's some lag on the camera. And it's going straight down, right? So now what I want to do is actually convert some of these things, because the problem is all the other values there are actually positions. So the magnitude of vectors here would actually represent what? If I just did the magnitude of the vectors between points up here, what would that magnitude be representing? I thought you said something. Okay. Yeah, the distance between, or the length of the ropes. If I just do the vectors as they are, the magnitude will represent the length of the ropes. I want the magnitude to represent force, or the weight applied, okay, or force in pounds. So what I need to do is actually figure out some vectors, and then I need to do a little bit of conversion with this. Okay, so for the vectors, if I look at these, I'm going to go from S, and I want to look at the amount of force that they're need to pull on that weight to keep it where it's at. So where should be going? From like S to P or P to S? P to S. Okay. P to S, well, no, actually, the vector there, sorry, would be going along that then. You actually want it to pull away from the weight. Everything's always, when you set up these kind of problems, you're always pulling away from wherever that weight source is. So you're going to go S to P for that. And I would also go S to Q and R. Okay, so I need to set vectors for these things. What would your vector be from S to P? In other words, just that 3 values. Say again? -2, 2, and 1. What about from S to Q? From S to P. So S to P, you're going to take P minus S, right? So you did it backwards and then halfway through switch. Okay, so 2 minus 0 is 2. 0 minus -2. 0 minus -1 is. Okay. Sometimes it does help draw out or actually write it out too, but most of you aren't anyway. So what's S to Q? 0, 2, 1. What about S to R? -2, -2. Okay. And the problem is, second. Okay. So I need to actually figure out the length of the ropes now. How do I figure out the ropes? Yeah, distance formula. So in other words, find the magnitude of P, the magnitude of SQ, and the magnitude of R. What would the magnitude of SP be? Square root of 9, 3. For SQ? Square root of 5. Square root of 9. Okay? Now, I want to convert this so that instead of looking at length of the ropes, I want to look at the amount of force applied to the ropes. Now, the way they are right now as vectors, there's no easy conversion. So what I need to do is change these into something that's going to be easier to then convert. Well, what can I change these to? One of the things we did yesterday. Unit vectors. If I shrink them down so they're 1 unit long, so I don't care about the magnitude anymore, I only care about the direction, then all I need to do is figure out what the multiplier is to turn it back into that force function, that force vector. So right now it's a length vector where the magnitude is represented in the length. I'm going to convert it so it's a unit vector, so magnitude is irrelevant, and then take that and convert it into a force vector. Okay? So convert those to unit vectors. Yeah, just divide each of the 3, whatever's over there. So what is your unit vector? And I'm going to call this the unit version, vector U, V, and T. Just so I don't have to write all these huge fractions. So for SP, what's the unit vector version of that going to be? 2/3, -2/3, and 1/3. What about for V there, S to Q? Now, actually, in this case, I'll leave it. I don't bother to rationalize those unless that's my answer. Okay, just because it's going to be easier with this most likely because things might go off. Okay, and it's just less to write as well. Oops. And for T, -2/3, negative, sorry, and then 1/3. Okay, so those are my unit vectors. So then I want to take these, I want to multiply them by some new value. Now that new value will actually be the magnitude of their force. That represents the force. What I want to do is take the magnitude of U times whatever's here. I want to take the magnitude times this, and then the magnitude of T times this. So I want to figure out what those 3 things. So then what I want to do with this is I want to set up a relationship between these vectors and this W here. Okay? Well, what is the relationship between all those vectors when we're talking about this? What should they ultimately do? If the object is being stationary, not moving, what should their combined forces be? 0. So the idea is I want to take these vectors, these forces, add them all up. So vector U, vector V, plus vector T, plus W vector, and have it be equal to nothing happening. So then what if I actually added U plus V plus T? No, u plus v plus t plus that w vector is 0. So u, v, and t put together is negative 480. Positive, because it's going to equal negative w. Right? Which that's going to cause these signs to flip. When I move it over, that's going to flip to 0, 0, 480. Okay. So what I end up having here is these equations equal to this. But these vectors are all made up of that unit vector times that magnitude. So what I actually end up having is 2/3 times whatever that magnitude of u is for the first coordinate, looking right here, plus the 0 times the magnitude of v plus negative 2/3 times the magnitude of t. Well, equal, what about w? 0. Because this is literally just the x values times each corresponding magnitude would equal the x value from w. The problem is I don't know magnitudes. That's what I'm trying to figure out. So for the v, the exact same thing. I'm going to take all the y values this time, and again they're going to be equal to 0. So negative 2/3, 2 square root of 5, and negative 2/3. And then what will my last equation be? So the exact is equal to 480. Yeah.
1/3 times
Magnitude, yep.
u plus 1/5
Times your magnitude of t. Okay. How do I solve that for 3 variables? No, we don't. How? Okay, the problem is these aren't, okay, predication might be throwing you here. This over here, these are all unit vectors. These all have a magnitude of 1, right? If I put 1s in, this doesn't work. I need to figure out what the magnitude of each one of these would have to be. So in other words, what do I multiply these by? What? System of equations. Ignore all the magnitude stuff. This is number x plus number y plus number z, right? So do a matrix. Make your life as easy as possible for this stuff. So if I do a matrix with this, whoops, I'm going to set it up where I have the 2/3, negative 2/3, 1/3. Vaguely remember this or not?
No.
How to use matrices to solve a system of equations?
Take the inverse.
Yeah.
I wouldn't actually bother inverse. We learned another way to do it. You could, but what? Reduced row echelon form. Gauss-Jordan elimination. That's the technique I would use, because if you take all those coefficients along with 0, 0, and 480, all into a matrix, all you need to do is RREF. Your calculator. Punch it in. Because the problem is all these vectors as they are all unit vectors.
Yeah.
So they're not showing me any kind of length going on. So I'm figuring out what the magnitude of the new vectors are. Say again?
I don't understand how that should support.
Because the magnitude of U or of W, the one that we wrote originally, that 0, 0, negative 480, right?
Yeah.
That number is referencing the force pulling directly down.
Yeah.
The three forces of the other vectors that are acting on the ropes in the directions of the ropes would have to add up to a point where they negate that, where they make it not move. Okay? So right now I have the direction, each of those. The direction is just the unit vector.
Yeah.
This is the direction. I don't know the magnitude of each one of those things. Because the magnitude in this case is going to represent the force acting on those ropes. Okay. Magnitude of the original ones when they just did coordinates,
Yeah.
that was coming from, that magnitude represented the length of those ropes.
Yeah.
Right?
Yeah.
But because we wrote that other one for W that was 480 units long, that represents the amount of force pulling down. So by setting them equal, what I'm able to do is find the amount of force instead of the amount of length of rope. The amount of force on each rope. That's what basically would work for this system of equations here. So that's what I'm doing with this. So basically, the original problem only gave me lengths, so I need to convert it to force. So the way I do that is change it so I get rid of the length entirely. I just have direction. Now I'm taking the direction and using the force I know, which is the 480 down,
Yeah.
to find the force on each rope.
So why don't you do 480 on each one?
Because it's not equally pulling on each one. 480 is only the force acting straight down. Okay, let's look at the answers, and I'll explain that further. Okay? Because it might be more clear once you see what the numbers are. What do you end up with for the magnitude of U? 360. For magnitude of V? 537. Magnitude of T? 360 again. Now each one of those are pounds of force, right? Now they're acting at individual points. This 360 pounds was acting at that point P. The 537 was at the point Q. And the 360 again was at the point R. Look at these. Actually makes a little bit because look at the position. Why would 3 be the same for both U and T at P and R? Why would the force of weight affect P and R equally? Because those are the same rope. You're going out to this position. Well, they're both starting at just this one's the 2 along the x, this one's negative 2 along the x. So overall, its position is going to go out to that thing because this thing's directly underneath your y because x is 0. So each one of these ropes. Why then is the other one 37 at Q? Why is that number so much bigger? Well, think about it logically. Where's this thing relative to Q? It's closer. It's underneath it. So the idea is this thing's not equally weighted. So like some railing or something they're tying to up here and then another point here. It's closer to this Q. So more of the weight's being pulled at that point. The rope's shorter because it's closer to that weight. So the force on that rope is going to be greater because it's more underneath this point than underneath 2 points. Does that help or not?
I get that, but I still don't have to do all that to get to.
Well, basically, it's because you're starting with length and you force.
Alright.
So you need to convert. It's only so the magnitude doesn't matter at all. So it's 1, and then you need to convert that with force. Yeah.
Can you explain with the system of equations why that last one is 480?
Because remember, with W was if we add them all up, it would add up to nothing. They would add up to 0 overall movement, overall force. So when I move the W over, it's equal to negative U. So that's going to flip all these signs. It just has to be negative 480 is the only one that matters that it's flipping. Questions on it? It's a fairly involved process, yes. So,
fair test question.
yeah, I could see this being one test question. There would be more than one on the test. Exactly one on the test.
Because it took us 20 minutes out.
I'm talking through every single little step, though, to be fair.
But we're also going to be thinking through every single step.
Well, not if you practice it a few times. If you walk into it fresh, yeah, you're going to be in pain.
This is gonna improve.
So, take a look at some of these problems now, because if you try to wait a couple days, that will hurt. Have at it.